Hello, so my name is Sebastian Faxer. I'm CTO for Ericsson New Zealand. I wanted to share this presentation on a little bit what is happening now in the telecommunication industry and how we are sort of changing the way both that we do the business and how we operate our networks. So if you take a step back and look on the sort of entire history of mobile network that we've been having from 1G up until 5G now. So essentially, when we started out in 1G and 2G, right, it was quite simple. We had one or two services, essentially. We did voice and we did text messaging. And the business model here was you essentially paid each time you used the service. So you paid per minute or you paid per text message. But then something happened and we had a large paradigm shift when it comes to 3G and 4G. So we introduced mobile broadband, where you essentially change the business model from a pay per minute to a pay per data model. And based on this mobile broadband, right, we added a lot of things on top of the connection. So we built the app economy, we had the Uber and the Spotify essentially monetizing the solution on side of the mobile broadband layer. And essentially the mobile broadband that we're offering now, it's what we call a best effort service. So you're not guaranteeing anything. You are not saying or guaranteeing that you will get a certain performance level. It's sort of it's what it is. And then you're running apps on top of this. And that's essentially how we are still using the mobile networks even after the 5G has been introduced. But what we're seeing now is another, I would say, fundamental paradigm shift where we are moving away from this kind of best effort connectivity into something new. So with the deployment of the 5G standalone service, we are we have the opportunity to do something much more clever and something much more better. So instead of selling just a data subscription, a unlimited data bucket, we are moving to a service-based architecture in the networks. And this means that we are offering different services with different performance requirements, and we are guaranteeing the performance for these different services directly. And the business model is no longer a data subscription in gigabytes. We are offering multiple service level agreements with a guaranteed performance level. Another trend that we're seeing is that we're opening up more of the capabilities of the networks when it comes to network APIs. So instead of just offering the traditional service, we're seeing that the networks are quite advanced and now can do more things. And that is an additional monetization opportunity for the network owners. And finally, we're seeing the trend that they're moving sort of from a single purpose network into a multi-purpose network that can handle all of these different services. And what do I mean with differentiated service and differentiated connectivity in other words? So essentially, we are moving from a one network fits all, where we only offer a single slice of the network with the same performance level for everybody. That is just delivered as a best effort mobile broadband connectivity. So sometimes this is labeled a dumb pipe, right? You're not really taking into account what kind of service you're offering over your connectivity. You're just providing the connectivity. Instead, we are moving to a network with multiple slices, where you might have one slice defined for doing real-time gaming, where it may be super important that you have very low latency and you have a guaranteed bitrate so that you don't get interrupted when you do your game. You might have another slice for a point of sales terminal that is assured that that terminal can always connect to the network and execute the payments, even if the network is super congested at a stadium when you have an event. You might have yet another slice that provides a live broadcasting, where you're guaranteeing that you have a certain large uplink bandwidth, so that the live broadcaster knows that it can get through its high quality uplink stream. and can use the mobile network for this instead of having to rely on another network like a satellite network. And when we have these different slices defined on the mobile network, what we also need to do is offer guaranteed and deterministic performance levels. So otherwise, this whole idea doesn't really work. And what I mean with deterministic performance compared to a best effort service is something I try to illustrate here. So even if you have a regular best effort mobile broadband service, sometimes your performance might be very good. You might having a low congestion scenario. You might be in very good coverage. But then over time, maybe you move into a high congested area where the performance level will drop. And there's no mechanism really to guarantee that the network can provide the performance that a certain service needs. So what we're moving on to now with the deterministic performance and a differentiated service is that the mobile network, meaning the RAN network and the core network, have mechanisms that guarantee for a certain user class and device and service level. You can actually guarantee with mechanisms in the network that this performance level is actually met. And we can offer this as a business solution with a guaranteed service level agreement. And then the business or the consumer that you will sell this service level agreement to can actually build its own use case and its own business on top of this, right? Because you as the connectivity provider has guaranteed that this performance will be sustained and will be reliable to that level of extent. And what that essentially means when we move into this kind of new paradigm is that you can expand the number of use cases that you can handle on your mobile network. So you can change, other use cases that might before have needed a dedicated network to guarantee this performance. You can actually change that now and bring those use cases onto the mobile network because you can offer a slice of differentiated connectivity with guaranteed performance. So this means that you can expand the usage of the mobile network into multiple new sectors. So for instance, a trend we're seeing is that more and more what we're calling mission critical services are able to move on to the mobile network because you can offer a guaranteed sort of level of performance. So public safety networks, utility monitoring, rail defense are some of these use cases that we can now support well with a mobile network where we have a 5G standalone. But there are also other use cases that are more in the traditional sort of MBB-like type of connectivity, where now we are adding on maybe cameras directly with the SIM card that require a guaranteed uplink slice. We have AI applications that might drive additional uplink traffic and require another certain performance level. We have AR, VR glasses that we think will hit big in a number of years. And the performance requirement for those use cases are much more stringent when it comes to the delay and the guaranteed throughput that you need to handle. So we're seeing an evolution where we tailor the service to each use case and we integrate that in the communication layer. And if you look a little bit globally, what is going on here? So this is actually, if you look on the sort of leaders in the industry, those that have had a 5G standalone deployment for a longer time. We might look on Singtel, for instance, in Singapore. So they have now changed their entire consumer offering to be on a differentiated performance scale. So they are offering something that they are, I think is similar to what you do on an airplane, right? So you offer the economy class and business class and first class. With different price levels, different performance requirements, and different capabilities. So all consumers in Singapore are now able to select sort of which differentiated connectivity class is actually applicable and suitable for them, and they can do that accordingly. Another leader in the industry that is quite far ahead is T-Mobile. So they have been offering differentiated connectivity using network slicing for a number of years. So they already have slices in play for mission critical services. live broadcasting, point of sales ticketing, a special connectivity class for drone communication, and so forth. So they have several use cases actually launched today. And they're, of course, working on introducing more of these into the network, like a special slice for gaming and a special slice for AR, VR type of glasses. So there's a lot of excitement. There's a lot of things happening in this area. So it's a very interesting time overall for our industry. Finally, another important thing that we are seeing happening with networks is that, as I mentioned before, you're not only offering the traditional connectivity using your network, you're also thinking about what other mechanisms can I use the capabilities that I have for the network for. And one important use case that we're seeing is fraud prevention and authentication services that can be offered with the help of the knowledge in the network. And that is then offered using a network API that application developers can use and integrate into their applications that relies on communicating with the network using an API that wasn't really there before. So for instance, in order to do fraud prevention, you might want to use a network API to verify that the number you are communicating with is accurate, that no one has changed and swapped around the SIM card lately, because that can be a red flag for that something quite fishy is going on. Another example of a network API is when we have this differentiated connectivity. Maybe you don't want to do this all the time, right? Maybe you want to say to the network that, hey, now I'm going to use this application that requires a different performance level and a different type of connectivity. So I'm going to ask the network using the quality on demand API to actually give me this heightened performance level of connectivity, and then sort of charge the consumer based on that request. Another example is that when you have your AR and VR glasses and you want to do this very advanced AI-based processing to interpret what you're seeing using the glasses and present that as information to you, typically that is too complex processing to be done on the AR glasses themselves, since the form factor is quite small. So what you can do is offload that compute to the cloud or the edge cloud using a network API. So you're calling the network saying that I have a compute load I want to offload. That is loaded off to the edge data server that is very close to the network. And then the result of the compute is fed back then through a network API using the AI glasses. That sort of maintains the low latency that is required. So there's a lot of different things that is happening in the network API area as well. So to summarize, how we are seeing the evolution of the mobile network is that we are moving away from this single service, a single use case offered that is best effort mobile broadband, to a differentiated offering where we have multiple services that each have different price points and service level agreements and performance levels. We are further introducing more and new use cases to the network based on this, because then we can offer a differentiated service category, we can move on new use cases to the mobile network and still make that work. And finally, we are utilizing new capabilities that is beyond the connectivity in the network. So by exposing network APIs, we can do things like fraud prevention, integrated sensing and communications, and authentication. So it's very interesting things that are happening with the mobile network. Thank you very much.